What is up everyone? Welcome to the second video in my Intro to Python tutorial series. In this video, I'll be going over some of the basic operators of Python and how we can actually get input from the user in our programs. The first class of operators we'll be covering are arithmetic operators. So addition is simply the plus sign. You can perform addition on integers and floats as you would expect. So it works just like addition in any other programming language. You can add integers together, you can add floats together, and you can add a mixture of the two as well. So when you add integers to integers, you get an integer. When you add floats to floats, you get a float. But when you add an integer and a float, the answer is also a float. So that's one thing you should keep in mind. Another thing the addition operator can do is string concatenation. So you can actually take two strings and join them together using the plus sign. You take one string like hello, you take the other string world, and then you just make a third string by adding string 1, string 2, and you can add a literal as well, which is this exclamation mark. So string 3 will become the combination of all three strings, hello world exclamation mark. Then we can look at subtraction. That's just simply how subtraction works. So you can only use subtraction on integers and float. It works just like addition. Integers subtraction leads to an integer, float subtraction, even if the answer is a whole number. So 1.1 minus 2.1 is actually minus 1, but since they're floats, so the answer is also a float, minus 1.0. And just like with addition, if you subtract an integer and a float, the answer you get is a float as well. Next up is multiplication. Multiplication is pretty simple. It's just this asterisk sign. Multiplying integers gets you an integer. 3 times 2 is 6. 1.1 times 2.1, multiplying two floats, it gets you a float. And you can see over here that the answer you get, it's not really exact. This is just because the computer has to round up the value to some degree. You should be careful whenever you're working with floats, because their value isn't necessarily always exactly equal to what you think it is. Similarly, when you're multiplying an integer and a float, the answer you get is a float. The multiplication operator, just like the addition operator, can also be used with strings. The addition operator was used for concatenation, but the multiplication operator is used for repetition. You can take a string, and if you multiply it with any number, and this should be an integer, the number n needs to be an integer, it repeats that string that many times. String 1 will be equal to this string concatenated 3 times. So repeat this, repeat this, repeat this. It just repeated that string. Then comes division. Division has two types. There's simple division, which is the division that we're used to. So if I just go through this, that's just the slash symbol. So 6 divided by 3 is 2. 1.1 divided by 2.1 is a float. 4 divided by 0.5 is 8. And as you can see, dividing integers by floats leads to a float as well. Dividing integers by integers also leads to a float. This is one difference of the division operator. What floor division does is it performs division and then just drops the fractional part. So when you divide integers, the result of floor division is always an integer. To perform floor division, you just use the double backslash sign. So 3 divided by 2, but this is actually floor division, so it'll drop the fractional part. If I just run this code, 3 divided by 2 is 1.5, but the fractional part was dropped, so it just got 1 remains, and it's converted to an integer. 1.1 divided by 2.1, since these are floats, so their floor division won't actually get you an int, but the fractional part is still dropped. Similarly, if you do floor division on an integer and a float, the answer is a float, but with the decimal point dropped. So after division, next up is the modulus operator, and it's just the percentage sign, and it performs simple division and returns the remainder of the performed division. So 6 divided by 4, the remainder is 2. So 6 modulus 4 will return 2. And similarly for all these other divisions, it will just return the remainder. So 2 is returned here, 1.2 here, and 7 divided by 7 modulus 2.0 is 1. And the last arithmetic operator we're going to look at is exponentiation. Exponentiation is just used whenever you want to raise a number to a specified power. The sign for it is a double multiplication sign. So what you do is 2 double multiplication sign 4. What this means is 2 to the power of 4. So that's 16. Then there is 2.2 to the power of 2.1. That's a float. And 2 to the power of 2.1. That's also a float. Next up are the assignment operators. We've already seen the basic assignment operator, the equal to sign. What it does is basically assigns a value to a variable. So x is 1, y is string 1, z is 2.2. This is just using the simple assignment operator. So one shortcut that we can use with the assignment operator, combining it with arithmetic operators, allows us to shorten some statements in Python. So for example, if you have this statement x is equal to 2 and you want to just add 2 to the value of x and store that value back into x. So one way of doing that is through like this: x is equal to 2 and then x is equal to x plus 2, where this will give us 4. Using the assignment operator, we can shorten this. We can just do x is equal to 2 and then instead of x is equal to x plus 2, we can write x addition symbol assignment operator 2. So this line basically means the same thing as x is equal to x plus 2. So if I run this, I'll get the same answer, which is 4. This applies to the other arithmetic operators as well. X minus equal to 2 is the same as x is equal to x minus 2. Similarly, multiplication, division, floor division, the modulus operator, and exponentiation. This should actually be double asterisks, but the Colab notebook's not displaying it correctly. Then there are some comparison operators that are available. These operators return Boolean values, which are true and false depending on the validity of a statement. So the first thing we can check is equality. So we have three numbers, 1, 2, 1.0, and a string. What we can do is we can compare the variables to each other. So I've written three statements here: x is equal to y, x is equal to z, and x is equal to string 1. X is equal to y, that's obviously not true. So 1, because 1 is not equal to 2, so it evaluates to false. X is equal to z, 1 is equal to 1.0. So Python is smart enough to convert floats to ints whenever you're comparing them with each other. 1 and 1.0, it knows that they're the same. So x is equal to z, it returned true. When you're comparing a string to a number, that's obviously going to be false. You can't really compare those. But if I was to cast this string into an integer and then compare them, the last print statement would give us true. So that's how you can compare a string containing a number to a number. Then there's the not equal to operator. What it does is the opposite of the equality operator basically. It returns true if the values aren't equal, and it returns false if the values are equal to each other. So it'll just return the opposite of the above. If I just remove this, false, true, false, and this is just the opposite of it, so it'll be true, false, true. It's the same numbers that are being compared. The not equal to is just an exclamation mark followed by an equal to sign. Then there's the less than operator, which is just this symbol. It returns true if the left value is less than the right, and false if it's not. It works with mixed floats and ints. X is 1, y is 2, and z is 1.0. If I just run this code, 1 is obviously less than 2, so the first statement is true, and 1 is not less than 1.0, so this one evaluates to false. Obviously there's going to be a greater than symbol as well. It's the opposite facing symbol from the less than one, and it will just return the opposite value. X is greater than y is false because 1 is not greater than 2, and x is greater than z is also false because 1 is obviously not bigger than 1.0. So then there are two more: the less than or equal to, and the greater than or equal to symbol. The less than or equal to operator returns true if the left side value is less than or equal to the right side value, and false if not. So x is less than y, that returns true, and x is less than or equal to z, so this also returns true because it's equal. Similarly, the greater than or equal to one does the opposite. X is greater than or equal to y, that's false because x is not greater than y and it's not equal to y either. And x is greater than or equal to z, so that is the case. 1 is equal to 1, so that will be true. Next up are logical operators. So logical operators are used to combine the results of comparison operators. So there are three logical operators: and, or, and, not. So first off is and. So this operator returns true only if all statements are true, otherwise it returns false. So if I write like two statements, one is this statement and the other one is this statement. The first statement says that x is greater than y, and the second statement says that x is equal to z. So and will only evaluate to true if both statements to its left and to its right, they evaluate to true. So is x greater than y? X is not greater than y. This is false. Is x equal to z? Yes, it is. So the right side is true, but the left side is false. And since both of them are not true, it will evaluate to false. The or operator returns true if any statement is true. Otherwise it returns false. And puts a condition that the left and right have to be true for it to return true, otherwise it's false in any case. But or is a bit more flexible in that it allows that either the left value or the right statement, they have to be true. So x is greater than y is obviously still false, and x is equal to z is true. So this will return true because one out of the two statements is true. And then there's not. What not does is it just inverts the result of any statement. X is greater than y and x is equal to z. This is the statement we saw first. So this obviously evaluates to false because the left side statement is false. But if we wrap it in a not statement, what will happen is it will take the result of this whole evaluation, which is false, and invert it, basically make it true. And the same goes for the next one. So this statement returns false, but the not makes it true, and this whole statement returns true but not makes it false. In this video, I just want to finish off with a small introduction to the input function. So what the input function allows us to do is ask a user for input during our program. So the basic way to ask for user input is just the input keyword. So what this does is it opens a prompt and the user can enter whatever they want. You can assign the value to a variable. Basically, if you want to use that value, you need to assign it to a variable. I input hello world, so this is now stored in user input. If I print user input, it'll print hello world. As you saw before, when we ran this code, the prompt didn't really tell the user what they were expected to enter. So we can also display a message along with our prompt to tell the user what we actually expect them to enter. We do that by just writing what we want to appear inside the parentheses of the input function. Now that string appears, enter your name. If I just enter a name, now user input has that name in it. One thing about the input function you should be aware of is that any value you enter will become a string. Even if you enter a number, it will be stored as a string. So if I enter a number 1 2 3 4, it is like a string. I printed its type and the type is string. So if you want to get an integer or a float from the user instead of strings, what you can do is just typecast the whole input function. So I just wrote int and parentheses around the input function. So what this will do is the user will enter an integer. It will be read as a string, but then Python will convert it to an int using typecasting. And then that value will be stored in user input. So if I just run this and I write a number, that's now stored as an integer. Also, one thing you should note, if you're converting to an integer, if you enter a floating point number, that will throw an error. Because this string 123.45, Python does not know how to convert it to an integer. So if we wanted a float, we could just use float instead of int, and 123.45. So that's converted to a float without any issues. And if you notice, if we enter an integer instead, it will just convert it automatically to a float. So that's it for this video. In the next video, I'll be going over some more advanced concepts. Basically, we will go over looping and conditional statements, if-else statements, and those will allow you to, make complicated programs that do lots of useful things. So I'll see you in the next video.